Hi, welcome children. Today I am going to explain about the unit 10 of the grade 9. Unit 10 of the grade 9. The unit 10 of the grade 9 is electrolysis. The unit 10 of the grade 9 is electrolysis. Right, let's go to learn about what is the electrolysis. Let's go to learn about what is the electrolysis. Right, before learn about the what is the electrolysis, you have to learn what is the electrolytes and what is the non-electrolytes. You have to learn, if not you should learn electrolytes and non-electrolytes. So let's go to learn about what is the electrolytes. What is the electrolytes? Right, the electrolytes mean liquid or solution. Electrolyte is a liquid or solution which conduct electricity. You all know normally the conductors conduct electricity, no? And also now some liquid and some solution have ability to conduct electricity. Such liquid or solution known as electrolytes. Right now we have learnt about what is the electrolytes, no? The electrolytes mean liquids or solutions. Which conduct electricity are called electrolytes. Right, then we will go to what are the examples for the electrolytes. Now we are going to learn about the examples for the electrolytes. The first one is salt solution. Salt solution able to conduct the electricity. Therefore, salt solution belongs to electrolytes. Right. Second one, copper sulfate solution. Copper sulfate solution is also able to conduct electricity. So, copper sulfate solution is also belongs to the electrolytes. Right. Next one, acidified water. Acidified water means water mixed with few drops of acid are called as acidified water. This acidified water is also able to conduct electricity. Therefore, acidified water is also belongs to a electrolytes. Right now we have learnt about what is meant by electrolytes, no? The electrolytes mean liquids or solution which conduct electricity are called electrolytes. After that we have learnt about three examples for the electrolytes. What are the three examples for the electrolytes you have learnt? The first one is salt solution, second one is copper sulfate solution, the third one is acidified water. Right, then we will go to learn about non-electrolytes. Now you can take the answer for the what is the non-electrolytes. If electrolytes mean liquid or solution which conduct electricity is known as electrolyte, so what is the non-electrolytes? The opposite term to the electrolytes, it means liquids or solution which do not conduct electricity. Liquids or solution which do not conduct electricity are referred to as non-electrolytes. Now we have learned about what is the electrolytes and what is the non-electrolytes. Right, then we will go to learn what are the examples for the non-electrolytes. The examples for the non-electrolytes are, one of them is kerosenes. Kerosenes is not conduct electricity. Therefore, kerosenes belongs to non-electrolytes. Second one, distilled water. Distilled water is also unable to conduct the electricity. Therefore, distilled water is also belongs to the non-electrolytes. Right, now we have learnt about electrolytes and then we have learnt about examples for the electrolytes. After that we have learnt about what is meant by non-electrolytes. Finally we have learnt about the examples for the non-electrolytes. Right, then we will go to learn about changes caused in a solution by an electric current. Changes caused. Some changes occur in a solution, especially electrolyte, by electric current. Right, now think about this is the electrolyte solution. Right, here contain electrolyte solution. Electrolyte solution means liquid or solution which conduct electricity. And also there are two terminals has connected to this electrolyte solution. One of them is known as cathode, another one is known as anode, right? Cathode means the negative terminal. The cathode anode means positive terminal. How to become the terminal as anode and cathode? When electric source is fixed, no? When electric source is fixed, here the positive terminal of the electric source, the terminal which connected to the positive terminal is known as anode, and also the terminal which connected to the negative terminal is known as cathode. Here the cathode anode, right? And also current flows from the positive terminal to the negative terminal, positive terminal to the negative terminal. Here the flow of electron charge, electron flows from positive terminal to the negative terminal, electron flows. Therefore current is electron flows from negative terminal to the positive terminal, negative terminal to the positive terminal. This is the way of flowing of electrons. The current flows opposite direction to the electron flows. It means current flows positive terminal to the negative terminal. This is the direction of the flowing current. This is the direction of flowing of the electrons, right? Like this terminal has connected to the electrolytes, and like that solution, if not changes can be occurred. When electrons, if not electricity, passes through the solution, lots of iron are floating around the here. Some changes can be seen in the electrolytic solution. When electricity passes through the electrolyte, some changes can be seen, right? This is the electrolysis. This is the electrolysis. This is the electrolysis. Right now we have learnt about electrolytes. After that we have learnt about non-electrolytes. Finally we have learnt about changes caused in a solution by an electric current, right? Then we will go to learn about what is the positive electrode. What is the positive electrode? Positive electrode means electrode which connected to the positive terminal of the electric source. The other names for the positive electrode is here anode, right? The electrode connected to the positive terminal of the external supply. The electrode connected to the positive terminal of the external supply of electricity is called the positive electrode. Positive electrode. Right now we have learned about what is the positive electrode. No, positive electrode mean the electrode connected to the positive terminal of the external supply of electricity is called the positive electrode, right? Then we will go to learn about what is the negative electrode. What is the negative electrode? The negative electrode means the electrode connected to the negative terminal of the external supply of electricity. The electrode connected to the negative terminal of the external supply of electricity is called the negative electrode. Negative electrode. Right now we have learnt about what is the positive electrode and what is the negative electrode. No, what is the positive electrode and what is the negative electrode? The positive electrode mean electrode connected to the positive terminal of the external supply is positive electrode. The negative electrode mean the electrode connected to the negative terminal of the external supply of electricity is called negative electrode, right? Then we will go to learn about what is the electrolysis. What is the electrolysis, right? Before learned about the electrolysis, we have learned about electrolyte, non-electrolyte, positive electrode and negative electrode. Right now we are going to learn about the electrolysis. What is the electrolysis? The electrolysis means the chemical change. The electrolysis is the chemical change effected by passing an electric current. Electrolysis is the chemical change, right? The electrolytes mean the chemical change affected by passing an electric current. Passing an electric current through an electrolyte. Through an electrolyte is known as electrolysis. Right now we have learnt about what is meant by electrolysis. Electrolysis, right? Then we will go to learn about inert electrodes. Inert electrodes. What is the inert electrodes? The inert electrodes mean the substances. A substance. Inert electrode is a substance that doesn't react chemically. That doesn't react chemically with the electrolytes. With the electrolytes. No, electrolyte means liquid or solution which conduct electricity. If and some substances does not react chemically with the electrolytes, such substances are known as inert electrodes. Inert electrodes. Now we have learnt about what is meant by inert electrodes. The inert electrodes mean a substance that doesn't react chemically with the electrolyte is referred to as the inert electrodes. Inert electrodes. Right now we have learnt about what is the inert electrodes. Then we will go to learn about what are the examples for the inert electrodes. Inert electrode. One of them is carbon, if not graphite, is the electrode which does not react chemically with the electrolytes. Therefore, carbon, if not graphite, belongs to the inert electrodes. Second one, platinum electrodes. Platinum is a substance that doesn't react chemically with the electrolytes. Therefore, platinum also belongs to the inert electrodes. Inert electrodes. Right, then we will go to learn about electrolysis of acidulated water. Firstly, I will tell you how to form the acidulated water. Acidulated water is made by addition of few drops of acid, copper sulfate or nitric or like that acid, addition of few drops of acid into water. Acidulated water can be made. Right, then we are going to learn about how to electrolyze the acidulated water. Acidulated water. Right, this is the way. This is the way. Right, firstly we have to take the like that apparatus and then add some acidulated water into this beaker, if not this apparatus. After that, two electrodes, especially graphite electrode or platinum electrode, are used here as connected to the external circuit. This is the positive terminal. This is the positive terminal of the external circuit. Therefore, this is also positive terminal. Positive terminal means anode. This is the negative terminal. This one is also negative. It means this is the cathode. This is the cathode. This is the anode. This is the anode. Right. And then when this electrolysis is occur, some gases is collected upper level of the test tube. Upper level of the test tube. What are these gas? Gas A and gas B. Right. If you can do this experiment, you can observe the gases collected in the, if not gases A is larger than the gases B. Approximately 2:1 ratio. There is a 2:1 ratio between the gases A and gases B. Right. So what is the conclusion? You can observe, is this gas is, what is this gas? For this you can use the different methods. You can use different method to identify this gas. Right. If glowing splinter is inserted to this test tube, the glowing splinter is produce pop sound. It means gases A is hydrogen. Here contain hydrogen gas. Hydrogen gas. Right. And also if we inserted the glowing splinter into the B1, it ignites well. So here contain oxygen. Here contain oxygen. Right. Water is the H2O. Water is H2O. When water is electrolysis, it becomes into hydrogen and oxygen. Hydrogen and oxygen. Hydrogen and oxygen. Here ratio between hydrogen and oxygen in the, now when we consider about the water, the ratio between hydrogen and 1 is 2:1. 2:1. Therefore, the gases collected in the upper level of the test tube also get like that ratio, 2:1. 2:1. So right, the conclusion of this experiment is, by the electrolysis complex compound can be converted into simple compound. Complex compound can be converted into simple compounds, right? This is also some picture relevant to the acidulated of electrolysis of acidulated water. Right. This is some video relevant to identify the electrolysis of acidulated water.
I'm going to show you an electrolysis of water setup. So we have a mini Hoffman apparatus, and I'm going to take this little test tube here, and I'm going to dip it under and fill it completely with a 3 molar sodium hydroxide solution.
One test tube has filled water like that.
Same with this one.
Another one is also filled like that.
So since we're starting with that completely filled up with solution all the way to the top here, it's going to allow us to collect gases in each of those.
After that,
so we're going to
positive
run
and
a red
negative
lead
terminal
to the
of the
negative
electrodes
terminal
can
of the
be
battery,
connected to the external
a
electrical
black lead
sources
to the
like
positive
that.
terminal.
After that, you can observe like that.
And when we do that,
some
you can see
gases are
bubbles
evolved
starting to
and collected
originate in
at
there.
the
I'm going to
upper
zoom
level
in
of
so
the
we can
test
see that
tube.
up close. And that gas is collecting on the left and on the right.
When gas is collected at the upper level, liquid level goes downward. This method of collecting gas is known as downward displacement of the water. You will be able to learn about it in the grade 10. The method of collecting gas like that way. Right. Now look at the gases contained in the here is and gases contained in the here. So what is the gas here? Here contain hydrogen. This one contain oxygen due to ratio between 2:1. 2:1.
1.5 milliliters of this other gas that easily ignites back into on fire.
Right, then we will go to our next topic. Right, again also you have to observe some video relevant to this one.
Electrolysis of water. This is an electrolytic cell used for the electrolysis of water. It is called the Hoffman's voltmeter. Observe the parts of the voltmeter. Acidulated water is the electrolyte taken in the limbs of the voltmeter. The electrodes, anode and cathode, are made of platinum. Anode is positive while the cathode is negative. Observe the circuit closely. Note that the anode is connected to the positive terminal of the battery and cathode to the negative terminal. On the passage of electric current, water dissociates into hydrogen ions and hydroxyl ions. At the cathode, the
Right. It can be examined that hydrogen gas evolved at the negative electrode, oxygen gas evolved at the positive electrode. Hydrogen gas evolved at the negative electrode, oxygen gas evolved at the positive electrode. Right. And also, if the gas evolved at the positive electrode is collected at the tested with a glowing splinter is put into it, the splinter reignite. This verifies that the gas evolved at the positive electrode is oxygen. Positive electrode is oxygen. And also similarly, if the gas evolved at the negative electrode is separated and a lighted splint is put into it, the gas burnt with the squeak clip of sound. Right. This confirms that the gas evolved at the negative electrode is hydrogen. Thus, during electrolysis, water is split into more simpler substances, hydrogen and oxygen. This is the conclusion of this activity. Right now we have learned about what is the electrolysis. Right. Now we will go to learn about applications of electrolysis. Right now we have learned about what is the electrolysis. Then we will go to learn about what are the applications of the electrolysis. Right. Electrolysis can be used in various fields in various applications. Right. The first one is extraction of various metal. Extraction of various metal. What are the metals that extracted by electrolysis? Example, sodium and aluminium. Sodium and aluminium are the elements, if not metals, that extracted by electrolysis. Extracted by electrolysis, right? One of the application of the electrolysis is extraction of various metal. Extraction of various metal. One of them is sodium, another one is aluminium, right? Next one, industrial manufacture of caustic soda. The caustic soda means sodium hydroxide. This caustic soda, if not sodium hydroxide, also manufactured by electrolysis. Electrolysis, right? Another one is electroplating. Electroplating. The electroplating means plating, if not applying one metals on the another surface. One metals on the another surface. For this process, electrolysis is used, right? Electroplating cannot be done without electrolysis. Right now we have learned about 3 applications of electrolysis. No, one of them is extraction of various metals. The second one is industrial manufacture of caustic soda. The third one we have learned is electroplating. Electroplating, right? Then we will go to learn about what is the electroplating, right? Now I have told you what is the electroplating. Electroplating means applying, if not coating, one metals on the another surface, right? The plating of a certain metal on another surface using electrolysis. The plating of a certain metal. The plating of a certain metal on another surface. On another surface using electricity. Using electricity is referred to as electroplating. Electroplating. Right now we have learnt about what is the electroplating. No? Electroplating means the plating of a certain metal on another surface using electricity is referred to as electroplating, right? Then we will go to learn about important things in electroplating. What are the important things in the electroplating, right? One of them is the metal that need to be plated. Sorry. The metal that need to be plated should be used as the positive electrode. So what should be the connected to the positive terminal, if not positive electrode? The metal that need to be plated. The metal that need to be plated should be used as the positive electrode. Should be used as the positive electrode, right? The another important things is the object that is plated. The object that is plated should be used as the negative electrode. Right now we have learned about 2 important things in the electrolysis. One of them is the metal that need to be plated. The metal that need to be plated should be used as the positive electrode. As the positive electrode, right? And then we have learned about the object that is plated should be used as the negative electrode. Negative electrode, right? Next important things of the electroplating. The electrolyte used need to be a solution of a salt, the metal that should be plated. That should be plated, right? These 3 important things you will be able to in our previous slide with examples. Now we have learned about under the important things in the electroplating. The metal that is need to be plated should be used as the positive electrode. The metal, the object that is plated should be used as the negative electrode. The electrolyte used need to be a solution of a salt of the metal that should be plated. As example, now think about if you want to plate the copper on the iron. Right now if you want to plate copper on the iron, so what should be the positive electrode? What should be the negative electrode? The metal that is need to be plated. Right, so positive terminal should be iron, the negative terminal should be copper. So what should be the electrolyte? Electrolyte is the solution of the salt of the metal that should be plated. It means copper sulfate solution. Copper sulfate solution, right? The characteristics of a high quality electroplating. Now we are going to learn about the characteristics of a high quality electroplating. What are the high quality electroplating? What are the characteristics of the high quality electroplating? The coating should firmly adhere to the surface subjected to plating. The coating should firmly adhere to the surface subjected to plating. And also the coating should be conform thickness. The coating should be conform thickness. The next one, the coating should be shiny. The coating should be shiny. Those are the characteristics of the
Electroplating is the process of coating one metal object with another. It works by electrolysis, which is when electricity is used to drive a chemical reaction. We're going to look at why you would want to electroplate, how it works, and various conditions that need to be considered. So why would we want to do electroplating? Metals may be electroplated for aesthetics, protection, or both. Aesthetics might involve making a metal shinier or giving it an attractive colour by coating. For example, jewellery is often plated with gold or silver. A metal coating can be used for protection, as it may help resist corrosion, rusting, or just general wear and tear. Car rims are electroplated for both shininess and protection. Chromium, commonly known as chrome, nickel, tin, zinc, and cadmium are often used to plate
those
copper,
are the
iron,
metals
and
that
steel of solution
apply
and connected with
electrolyzing.
a battery or power supply. So we end up with a setup that looks something like this. When the current is turned on, the electrodes gain a charge. The positively charged electrode is called the anode, and the negatively charged electrode is called the cathode. The electrodes in an electrolyte are carefully chosen based upon what metal you are plating. As an example, brass, producing the... So in conclusion, from this video...
Right. This is the way. This picture represents the application of the copper on the iron key. Right, here contain copper. Right, it means copper should be anode. The metals that should be plated connected to the cathode, if not negative terminals. The electrolyte should be copper sulfate solution.
The idea of electroplating is like this. Okay, let's say we have a key. And then we want to electroplate this key. Okay, let's say this key made out of irons. Okay, and irons can rust easily. We want to prevent rusting, so we want to electroplate this key with layers of copper. We want the copper to cover the surface of these irons. So the idea is we use copper metals. Okay, the atoms of the copper metals will go to the surface of the key here and then stick on the surface of the key. That's the idea. Okay, in electroplatings, the very first things that we need to know is, okay, which one you take it as the anode and which one you should take it as the cathodes, anode or cathodes. Okay, so if you want to electroplate a key, okay, so should you put the key at the cathodes or should you put the key at the anodes? So which one should be the cathode and which one should be the anodes? Now here, okay, obviously, okay, because it's already labeled here, right? Okay, it's already labeled here. So the key is the cathodes, and the metals that we want to electroplate on the key is the anodes. But the question is, why the debate solution, the cathode? Okay, so if the key is the electrolyte to use, okay, now.
Right, then we will go to application of electroplating. What are the application of electroplating? Electroplating nickel metal on iron tray, protect it from rusting and also give it an attractive appearance. Right, nickel metal can be coated on the iron tray. Right, when nickel metal apply on the iron tray, it give a brightness color and it protect from the rusting. It is the application of the electroplating. The another one is electroplating of copper jewelry. Copper jewelry can be plated by the gold. Electroplating a copper jewelry with gold add a value to it and gives it a rich look. Any metals can apply the gold. Right, those are the application. Then we will go to discuss about what is the copper plating. In the copper plating, positive terminal should be copper, the negative terminal should be metal. The electrolyte should be copper sulfate. Copper sulfate. Now think about, in the copper plating, positive terminal should be copper, the negative terminal should be metals, relevant metals, right? The electrolyte should be copper sulfate solution. After that, the copper from this here come and deposit on the metal. Deposit on the metal. This is the copper plating, right? Now when we consider about the silver plating, the positive terminal should be silver, the negative terminal should be metal. Therefore, the silver contained in the electrode, anode, and deposit in the spoon. It means metals. Gold plating. In the gold plating also, positive terminal is gold, negative terminal is relevant metal. The electrolyte is gold cyanide solution, right? Right now we have finished this lesson. Under this topic we have learned about what is the electrolytes, non-electrolytes, electro changes that can be seen when electricity passes through the electrolytes. After that we have learned about positive electrode, negative electrode, inert electrode, and then we have learned about electrolysis of acidulated water and observation here. After that we have learned about application of the electrolysis, and then we have learned about the electroplating, important things in the electroplating, and finally we have learned about application of electroplating, right? Next I will explain next unit of the grade 9 science, right? Have a nice day.